Hi there everyone. So in this video we are looking at the hyperbola function, and we'll start with the standard equation of hyperbola. So it goes y is equal to a over x minus b plus q. Pardon me, I mean to make this a positive. Okay. So what do these variables in the equation mean? Let's start with x and y. So x and y are the variables. It's either the input or the output. Okay, x being the input, y the output. And these the variables a, p, and q are merely in place of a number. Okay, so they're just standing in the place of a certain number. The questions that you will look at will all have numbers in place of them, or if they don't, you would have to calculate their values. But they are basically just numbers, or standing in the place of a number. So what is, like, if p was a certain number, what effect does that do to the graph? Well, p will move the graph either left or right. Left or right. Okay, now the reason I say left first is because if p is positive, the graph will move to the left, and if p is negative, the graph will move to the right. Now if you remember, a hyperbola looks something like this. Okay, either drawn in the first and third quadrant, or the opposite, second and fourth quadrants. But let's say it's drawn in this first and third quadrant. We always have this vertical asymptote being on the y-axis. So when the graph moves to the left, the vertical asymptote moves with. If it goes to the right, left, and if it goes to the right, the vertical asymptote will also move with. The same for the horizontal asymptote. Okay? If this graph must move up or down, then the horizontal asymptote will move with that. And Q is our indication of the horizontal asymptote. So this is the up or down movement or shift. Up will be positive, down will be when Q is negative. And just like I said, this is an indication of the y asymptote. Okay, in the same way, X is an indication of our X. In the same way, P, pardon me, is an indication of our X asymptote. Okay, A simply tells us the shape of the graph. Okay, so in this case, if A is positive, the graph would look like this. And if A is negative, the graph would simply reflect in the x-axis or y-axis. Now, hyperbolas are best explained with an example, so I'm going to use an example to do that. So here's our example. Y is equal to 4 over x minus 1 minus 2. And also I'd like you to draw your Cartesian plane next to you, because we're going to be drawing this function over there. Before we can do that though, you should first know how to calculate a couple of things, such as the x-intercept, the y-intercept, and the asymptotes. Okay. Oops. Asymptotes. So, firstly, the x-intercept will be easy. We can just make y equal to 0 and we solve x. The y-intercept will also be easy, because then I make x 0 and I solve y. Asymptotes will read off the graph. So this is x minus 1. That means that the graph is shifting 1 unit to the right, which would mean that our asymptote will be on the positive side. So the current asymptote is here at 0, but the minus 1 shifts it to the right. It will be at positive 1. The y asymptote, the horizontal one, also at 0, and the minus 2 brings it down 2 units. Okay, so in fact I'm going to plot that in immediately. Let's start with the y asymptote. That's the horizontal one. Y is equal to -2. I'll write it here. Y is equal to -2. Then the x asymptote, that's the vertical one, which shifted 1 unit to the right. It should be a completely vertical line. X is equal to +1. And that came from our P and Q values. Okay, what do we need to do next? Work out the X and Y intercepts. Let's start with the x-intercept. So we'll make y 0 and we'll solve x. I'm going to take the 2 across. I'm going to cross multiply. So this times the 2 and 4 times the 1. Then I'll take the 2 across, add it with the 4, and therefore x is equal to 3. So my x-intercept is 3. Now to work out my y-intercept. So we start off by making x 0. Then 4 over -1 is -4. If you minus 2 from that, you get -6. So the y-intercept is -6. Let's plot all of this. X-intercept is 3. Y-intercept is -6. Now, can we draw a nice smooth hyperbolic curve through the points? So one part of the curve will be in the first quadrant, like that, and the other part will be in the fourth quadrant, or third quadrant, pardon me, like that. Okay, and that's it, guys. That's how you draw a hyperbola.